Okay, so this is lesson 7, add and subtract rational variable expressions. So far this unit we covered exponent rules, introduction to rational functions, we talked about the transformations, then we started to talk about rational variable expressions, we learned how to simplify them. Recently we did multiplying and dividing, and this is the last lesson on how to add and subtract. Basically for this, you can look at RVEs, which is a short form for rational variable expressions, as fractions. And we all remember from when we first learned about fractions on how to add and subtract, we need to determine the lowest common denominator between the two fractions. So here's a warm-up. We have the fraction 2 over 3 plus 1 over 4, and the lowest common denominator, the denominator in this is 3 and 4. So we need to determine multiples of 3 and 4 that are common, and we need to determine the lowest one. So to find this out, you can list the multiples, or as we already know, or most of us know, the lowest common denominator is 12. And we don't need to solve this, so you can just write the lowest common denominator is 12. The second one is 2 over x bracket x plus 4 plus 1 over x. So now we're introducing variables in the denominator. So like we never really learned about how to determine the lowest common denominator of this before. So all we need to do is multiply the second fraction, which is 1 over x, by x plus 4. Because as you can see, both sides have x, but the second fraction doesn't have the bracket x plus 4, which it needs, so we can add it. So the lowest common denominator is obviously going to be x plus 4. Okay, so here we have adding and subtracting RVEs. So as I said earlier, RVEs are added and subtracted in the same way that rational numbers, or commonly known as fractions, are added and subtracted. And the key thing to remember is that you need a common denominator before you combine the two fractions, whether it's adding or subtracting. So you always need a common denominator. So here are some of the steps for adding and subtracting. For first, you must factor both the numerator and the denominator, not the denominator itself. The second is you need to state all restrictions. Third is you determine the lowest common denominator by finding the multiples of the denominators, or to see which one is missing from where, if you're dealing with variables. 4 is multiply each expression by the missing factors. And 5 is you add or subtract the numerators, but you keep the denominator the same. Because if you were to add or subtract the denominators, then you might get an undefined fraction, or it just might not be good communication, and you might get the wrong answer. Okay, here we have our first example, and here it tells us to simplify the following RVEs and straight the restrictions. So the two RVEs are 2x plus 3 over x squared minus 2 subtracted by x minus 4 over x squared minus 2. So first we have to see if the denominators are the same. And as you can see, these fractions have the same denominator, so we can carry on to subtracting the numerators without finding a lowest common denominator, because the denominators are already the same. But before we begin doing that, we must state the restriction. And as you can see, the restriction is 0, because if x equals 0, then the fraction will be undefined. My second step here, I just subtracted 2x from x and 3 from 4. And as you can see, I put 3 minus negative 4 because it's minus 4. It doesn't mean that the subtract sign doesn't affect it, because it still does. You can think of multiplying the whole second fraction, the numerator, by negative 1, and then combining it with the numerator of the first fraction. And as you can see, 3 minus negative 4 is basically 3 plus 4, which is 7. And my final fraction is x plus 7 over x squared minus 2. And you can't simplify this anymore, so all you have to do is write the restriction. And it is important to write the restriction at every stage, as you will get good communication marks on your unit test. Okay, here's another harder example. This again is asking us to simplify and state restrictions. So as you can see, our first fraction and our second fraction, the denominators are not the same. And our first step is to factor. The numerators are both factored fully, and the denominator for the second fraction is already factored fully. The denominator for the first fraction, however, can be factored, and it is a complex trinomial. As you can see on the right side, I showed all my full steps to factoring a complex trinomial, and I ended up with the brackets 2x plus 1 and x plus 1. On my second step, I stated my restrictions, and my restrictions are negative 1 over 2, which I got from the first bracket, and negative 1, which I got from the second bracket, x plus 1. Then I looked for a lowest common denominator, and I noticed that both the first fraction and the second fraction have 2x plus 1, but the second fraction lacks x plus 1 in its denominator. So the smartest thing to do will be multiplying the whole fraction, the top and the bottom, by x plus 1. On my third step, you can see that I expanded I got 2x plus 2 from expanding the 2 times x plus 1, and I added it with 4. So the numerators are adding because the denominators are the same. And the denominator is 2x plus 1 and x plus 1. That leaves me with the final fraction 2x plus 6 over 2x plus 1, x plus 1. And this cannot be factored anymore. Well, the top part, the numerator can, but there's no point in factoring it because you cannot cancel out any more fractions. So it's alright to leave it the same. It only makes sense to factor it more if you can cancel out any thing on the bottom. And again, I labeled my restrictions on the side, and it stayed the same throughout. My restrictions were negative 1 over 2 and negative 1. Okay, so here's our last example, and it is a much harder one. The two fractions are a over a squared minus 25 subtracted by 2 over a squared minus 9a plus 20. So first you want to factor both the numerators and the denominators. The numerators are factored fully. The denominator, the first one, however, I factored it to a plus 5 and a minus 5. For the second one, I factored it to a minus 5 and a minus 4. And that I got from negative 5 and minus 4 are two numbers that add up to negative 9 and multiply to 20. And then I labeled the restrictions on the side. The restrictions are negative 5, 4, and 5. Next, I looked for a lowest common denominator. The first fraction had, both fractions had a minus 5. The first fraction, however, did not have an a minus 4. So I multiplied the first fraction by a minus 4. The second fraction did not have an a plus 5. So I had to multiply the whole fraction by a plus 5. So I did that, and then again I labeled my restrictions on the side, and I got a squared minus 4a for the first fraction's numerator, and 2a plus 10 for the second fraction's numerator. Next, I just simplified. Again, if there's a negative, you can treat the subtract sign as a negative 1 and multiply the numerator by it, or you can just write it the way you can just write it simply altogether. And I stated a squared minus 4a minus 2a minus 10. And I got a squared minus 6a minus 10 over a plus 5, a minus 5, a minus 4. And my restrictions, again, they all stayed the same. And I labeled it in each step, which is good communication. You can't really factor the numerator anymore. So this is the final step. Hope you guys enjoyed the lesson, and you guys should really do good on your test.